Good morning, good afternoon, and good evening. Thank you for joining us for Cold Storage Gridlock, Unlock It with the new ULC-259. I'm Lauren Berry, your event moderator and executive assistant for Trane Technologies Life Science Solutions business, FARRAR. I'm joined today by our speaker, Scott Masella, our Life Science Solutions portfolio leader. All attendees have been placed in listen-only mode. This presentation will be recorded and is best viewed using the GoToWebinar software for PC or Mac, or by using GoToWebinar app on a smartphone or tablet. If you have technical difficulties, please send a message in the chat window and we will attempt to troubleshoot your issue. During this presentation, you will have the opportunity to ask our subject matter expert questions using the question window in GoToWebinar. Once the presentation has concluded, our speaker will be answering your questions live in a session. Let me share a little background on our presenter today. Scott manages the life sciences portfolio of products and solutions for Trane Technologies, including FARRAR rate freezers and storage freezers, walk-in cold rooms, and integration of core technology into life sciences. As part of Trane Technologies, he embraces the goal of reducing the world's carbon emissions by 1 gigaton by 2030. Scott has traveled internationally to understand the needs, concerns, and problems that confront biological storage in labs, manufacturing facilities, and biorepositories. Conflicts between sample security and sustainability are at the forefront of nearly everyone's mind. With more than 20 years of experience while holding positions of progressively increasing responsibility in engineering and product management, Scott has gained a deep understanding of how to apply innovative technologies, techniques, and products to solve key customer problems. Recognizing the challenge of adopting sustainable practices and tools without compromising quality can be daunting. He has collaborated with numerous teams to provide cutting-edge solutions that contribute to achieving their sustainability goals. Scott holds a bachelor's in mechanical engineering from Tufts University in Boston, Massachusetts. I will now turn it over to Scott to begin our presentation.
Good morning, good afternoon, good evening, everybody. Thank you for taking the time out of your day to listen, and thank you, Lauren, for the introduction. Today, I'm really excited to share some market trends and a new product launch, the ULC-259. I think you'll find that it can solve a number of challenges that exist in the biopharma manufacturing, storage, and logistics spaces. And let's dig right in and see where we're going to go next. All right, the agenda slide. A key part of any of our presentation, but during this webinar, you'll hear about common challenges facing biopharma, logistics, and storage sites, key features that help solve these challenges that are in all of our ULC sizes, specific details about our new ULC-259, and some interesting tools and solutions that can be leveraged to solve other challenges you may have in your business. Let's dig in and starting with the market challenges. For the past 6 months, FARRAR has interviewed, visited sites, and conducted Teams calls with customers and noticed a shift in customer priorities for biologic drug manufacturing. First, the shift from rapid drug discovery using technologies such as mRNA and rapid scale-up in manufacturing has moved over to process improvement or process intensification to increase yields in batch sizes. A good example of a macro shift in this area has been the Inflation Reduction Act in the US. One of the provisions includes limiting price increases on pharma and biologics to inflation rate only, or you'll end up paying the government a rebate. Driving yields up in biologic production is a clear leader to improving profitability. In order to do that, trimming the fat out of a process, including the handling steps, and working around the freeze, store, and thaw steps are areas that definitely need to improve. The second key area is a direct focus on the steps involving cold storage, bulk storage, and freeze down. Is there a way to improve freezing time or increase or decrease batch sizes to meet, or easily increase or decrease batch sizes to meet demands? Can you do that without having to build around a particular ULT freezer, as an example. In the pull, pack, and ship steps, the most common bottleneck is freezer access due to recovery times. How do you reduce the time between door openings? Can you pull more or less and infrequently, or can you get a freezer that can really meet the demand that you have? How do you reduce the time also between the door openings to not jeopardize the samples and triggering a high temperature alarm? If a process changes and stability data of a biologic drug suggests it can be stored at a warmer temperature, are there tools within your existing cold storage equipment that allow you to change that and still meet your manufacturing requirements around temperature uniformity and recovery? Is there a way to streamline preventive maintenance and speed up the break-fix time frame so you're not down a line each time the freezer goes down? The final key of the problem has space constraints for freezers. As demand for storing samples increases with new biologic drugs and research projects related to those, on-site storage becomes a big challenge due to lack of space. You could expand into larger buildings, you could expand to different sites, but a lot of times you feel like a landlocked city. The only way to really grow is more density or grow up. Let's see what you think the most valuable requirement or feature is with your freezer next in our poll. It's very interesting. As I'm looking at the stats, driving the bus here is freezer temperature uniformity with a close second of fast door recoveries. That's awesome. So we're going to dig into some of that next. So let's move on, Lauren, and we'll talk a little bit more about refrigeration systems. So before we can talk about the ULC family's refrigeration systems, I wanted to ground everyone in the types of freezers that the vast majority of users have and what that refrigeration system looks like. So when you have whether you have a Cascade compressor system or even a Stirling engine, whether your refrigeration system is on top or on the bottom, the thermodynamics I'll explain here are basically the same. In essence, this process relies on natural convection to move energy or heat from material and air within the chamber to the outside ambient. If you think about a space moving toward equilibrium, heat within the air and product move outside the product, also known as the freezing process, and are represented by the red squiggly arrows here in this diagram. Natural convection moves the heat or energy towards the wall of the chamber, and the wall of the chamber is refrigerated. This is where the cold wall name comes from when we talk about cold wall ULT freezers. The wall of the chamber absorbs the heat, and natural convection also moves that energy or heat around to the wall evaporator to the refrigerant, which is pumped around the system and released as heat to the ambient. This is a really effective process, especially if you're looking at long-term storage. Very energy efficient, very simple. The downside, of course, is if you open the door, that process to reach equilibrium takes time again. So let's take a look at the ULC's refrigeration system to see the bit of difference. Achieving a temperature equilibrium in this refrigeration system is also is a tailwind to the work this system is doing. So natural convection is also wants to work in this space too. However, we don't really allow it to happen because we're in the forced air convection system. A blower forces cold air into the chamber and forcibly removes the energy or heat from the contents in the chamber air. These are represented by the straight red arrows. Big difference being that we're moving it and pushing it, so the airflow, as you can think about it, is moving pretty fast. In fact, we're doing an air change every 2 seconds in our ULC family, or 500 CFM, cubic foot per minute, which moves the energy to the evaporator much more quickly than a natural convection cold wall system. From there, the energy is absorbed by the refrigeration evaporator and circulated back to the space to repeat the cycle. This system, of course, consumes a higher amount of energy than natural convection cold wall freezer would, but only while there's a significant heat load, such as a door opening or added material. And that difference is really that blower motor. Let's take a look at the other critical features of the ULC. So when you hear about our ULC family, the first thing you hear about is how it's fully redundant. But what does that really mean? Well, we have 2 refrigeration systems that could each maintain minus 80 degrees C even after frequent door openings. One refrigeration system has more than double the available cooling capacity of a standard cold wall freezer, and it's a whole complete system. But we also have 2 dual human-machine interfaces, or HMIs, that each can control the system when the other is offline. So you have 2 normally. You can control either the one on the left side of the door or the right side, doesn't matter. And if one goes down, whichever one is left will control the whole system. Finally, we also have redundant power supplies that allow connecting to 2 unique circuit breakers. So with the exception of the chamber, the entire freezer is completely and fully redundant all the way back to your site's power. But let's dive into the most important component to our freezer, the refrigeration system. So a single refrigeration system can maintain, one back, Lauren, just for a second. A single refrigeration system can maintain minus 80 C or warmer, even with door openings. So when there is a door opening, however, both refrigeration systems activate, and the refrigeration capacity doubles to quickly recover from that door opening. This also gives you the ability to achieve good energy consumption and only really use the added refrigeration capability and capacity when you need it most. So during steady state operations, 1 unit runs to maintain temp, saving energy and giving users the best of both worlds. The units will also alternate as primary automatically during regular operations, so maintaining even loading on both units throughout their life. Let's dig a little deeper into that refrigeration system a little bit more. So we've talked about dual refrigeration systems, and when you think of redundant refrigeration systems, you think backup in case one goes down. Absolutely true, but we've added additional intelligence that really gives you the cooling capacity and power that you need when you need it. So the first area I want to talk a little bit more about on our ULC is its auto defrost. So the hallmark, it's really the hallmark of what we do that really makes us different. So our automatic defrost runs regularly to ensure performance is maintained without icing over. Unlike freezers that require manual defrosting, the defrost rate and time on our ULC can be set while the unit is in service. That means there's no reason to take the freezer out of service for 2 or 3 days while you wait for it to thaw and put it back into service. So no loss to recovery times, no degradation of uniformity due to icing. All you really have to do is vacuum with a shop vac the snow that accumulates at the bottom of our freezer. And that snow happens anytime that you don't remove humidity from your environment. The units also work in tandem to provide additional cooling capacity, as we talked about, to quickly return the chamber back to steady state. And once steady state and temperature is stable, again, the refrigeration system returns to single unit operation and saving a great deal of energy. In fact, our ULC-190, pictured here, is a top 10 performer on the Energy Star website among ULTs in terms of its energy consumption, while also maintaining a very, very tight temperature tolerance compared to others around it. It's really a plus or minus 3 degrees C unit, and you can see that unique difference right inside the Energy Star website. So no units No reason to take this unit out of service to thaw it like you'd have to do with a standard ULT and really get good energy consumption. Now let's dig a little bit more into our newest product, the 259. So here's your first peek, and I'm really excited about it. Big things come in short packages. Any sort of unique like tagline you want to name to it, it's pretty nice. So it's an 84-inch high chamber providing 259 cubic feet of storage. Taking a look at the bottom graphic, you'll see our standard ULC, branded the ULC-190, our ULCP, which is now the ULC-311, and our new 259 unit. That Silver Surfer, for those Incredibles movie fans out there, is a 5'8" model in front of the freezer. And as you can see, that ULC-259 allows you to access all locations of the freezer from the ground. So ideal for frequent freezer access, especially when fitted with material handling solutions for your particular process. And speaking of material handling options, the 259 has shelves, carts, and sliding shelves with racking options already ready to go. And we'll talk about those in just a bit. But finally, with the release of the 259, we've added integrated connectivity via Modbus to export all of the points measured in our freezer to your monitoring solution, whether it's a building management system or an automation system, or just a custom monitoring solution from any temperature monitoring company you might be using. Our protocol should be easy to integrate and allows you to really dig and predict any issues that might come up before you have a temperature alarm. And nobody likes driving their car with no indication or warning level before the steam comes out of the hood. Same thing with freezers. We like to be able to provide indications of what's going on with our freezer before a temperature alarm happens. And so let's take a closer look now at the ULC-259's performance next. Our empty per chamber performance at minus 80 C is plus or minus 1.5 degrees, any point in the freezer. With a max temperature of minus 78.5 and a min temperature of minus 82, it's well within the tolerance of a customer's uniformity requirements. The tighter spacing between that sawtooth in the middle of the graph was for our engineers optimizing the blower motor speed to see if that really mattered. And as you can see, uniformity doesn't change that much in terms of max min. It just gets a lot closer and tighter between temperature swings between those 4 degrees. So the takeaway here is we're really maintaining a really tight temperature tolerance across the freezer with the warmest point along the door gasket. The largest heat infiltration area in the freezer and the coldest point is near the evap motor and blower at the top of our ductwork. So let's take a look at how the performance looked when you ghost load it. So I mentioned ghost loads on the last slide, and most people are shaking their heads and wondering, like, what is he talking about? Well, what I mean is you'll see we loaded the freezer with empty boxes. So for the purposes of challenging our forced air ductwork. So I didn't want to provide a fully loaded freezer that gives a thermal mass and also helps contribute to great uniformity. But I wanted to give the ability to challenge our forced air convection. So we ran the study at minus 70 for just to see what it would behave like. And we ran it at minus 70 because we know that there's a lot of biologic drugs in their final fill and finish state that would be stored at minus 70. And what you'll see here is that we're at plus or minus 2.5 degrees with the warmest points are right in front of the door. As you can see that right by that top bar at the top. And so in fact, without including the door, we're back at that plus or minus 1.5 C from the empty chamber. So let's look at an even warmer set point next. I think one more in front of that one, Lauren. Thanks. In many cases, Cascade refrigeration ULTs struggle to achieve uniformity goals at warmer temperatures. The ULC-259 performance, however, is driven by the forced air convection and the ability to circulate that air around the chamber to keep it quite uniform, even between activating the refrigeration system. So this unit, you'll see, is quite uniform, meaning it's plus or minus, it looks like about 1.5 or 2 degrees or so. And what you'll see here also is that the unit was calibrated for use at -80, and so the mean temperature is around -41 instead of -40. And you'll see that by that kind of that brown sweep in the middle. So during cooldown cycles, points in this chamber can hit -43.5 or so, but for the most part, the freezer maintains very close to the set point. So let's dig into our material handling options next. The ULC-259 integrates inner door drop-down doors and sliding doors to provide users with the ability to pick and place from the ground in a very deep freezer. So using the same racks as the standard ULT freezer, the density improvement here is dramatic. So on the chart, you can see comparisons between storage capacities for 2- and 3-inch boxes and also blood boxes. These blood boxes are the typical boxes that you might have 1 unit of blood stored in. And the ULC-259 numbers include our left and right doors. And as you can see, it's significantly more dense than the ULT. However, it's not really fair to compare a unit that's significantly larger than a standard ULT. So what we did was we figured out how many ULTs can fit in that ULC-259 footprint, and then we represented by the column ULT at density. And you can see some significant improvements. If you were to fit 6 units, standard ULT units in that footprint, we still are significantly more dense, while also giving you ability to pull those samples from the ground. Let's take a look at some other options we have too. So the flexibility of the ULC-259 extends the processing as well. So we notice in our customer visits and meetings that loading heavy bags or bottles from one location to another can be cumbersome and repetitive. So our cart systems are customizable for your applications, from carboys to shells and bags to final packaged boxes and vials of syringes. We work with users to make sure the ULC fits in the process you need and not fitting your process into the freezer limitations. Taking a closer look at this particular rack, at this particular cart, you'll see a cart within a cart. So this traveler cart with that slight angle allows you to move the cart or move around in your facility and into our freezer without having to customize a floor and a door like a built-in solution might have. This allows you to put the freezer wherever you want in your facility and be able to load carts in and out of the freezer quite quickly and quite easily without, like I said, having to have a built-in system in place. Much lower cost, much easier, much more maneuverable, and much quicker. Let's take a look at some other areas that FARRAR can help. And I think it wouldn't be an informative presentation if we didn't touch on some of the other key products that we have in the biologic, drug, and life science space that can support the core set of markets and users as our new ULC-259. So in addition to reach-in solutions, we also engineer, install, monitor, and service a complete set of walk-in solutions. We've installed many types of freezers across North America, including blast freezers or extra, otherwise referred as extra cooling capacity freezers that can freeze and store biologics for transport immediately after a donation or immediately after fabrication, constant temperature solutions for really tight temperature tolerances, and then controlled clean rooms. What makes us different is our ability to work with you in determining the most efficient way to use your controlled space. From material handling solutions that minimize the human handling to unique trolleys or doors to minimize air infiltration from frequent door openings. We support you on your engineering firm in building a space that you won't grow out of or grow tired of in a short period of time. We also offer nationwide installation and services. This is really helpful as you'll get consistent results and consistent service, no matter where in your organization is and where you might need to install the space. We also leverage train tracer ensemble monitoring capabilities to monitor not just temperature, but all of the mechanical points in the refrigeration system. So the tracer ensemble monitors the points within the freezer, also identifying areas of concern well before a temperature excursion. This allows us to provide service before a temperature alarm and before it's a critical problem. We also help to provide customers with feedback on their use of the space, such as door opening frequency and duration, to improve the cold space inside, easily seen on that tracer dashboard as well. Now we've talked a little bit about fixed units. Let's get more into what we can serve in the space for mobile and transportable solutions. So besides cold rooms and reach-in solutions that support product development and manufacturing, Trane Technologies also supports transportation of biologics with temperature-controlled mobile solutions. We'll talk about one of those offerings on the next slide, but in many cases, frozen bulk material is shipped to a manufacturing organization where it's thawed and packed in the final fill and finish state. Our super freezer is a great choice for large volumes of bulk material, eliminating the need for passive cooling like dry ice, which is becoming increasingly difficult to make with the global helium shortage. Our control rate chamber offers precision freezing capability for bags and bottles, and it also offers precision thawing in the same freezer. And for more information on that, we've got a webinar that you'll want to listen to on our website called Burned Out from Burning Out Your ULT Freezers. But let's take a closer look at mobile or temporary storage, a storage solution, next. So another unique offering Trane Technologies has recently released is an ultra-low class of shipping containers. The super freezer is a mechanically cooled shipping container with a temp set point between -10 degrees C and -70 degrees C. It's powered by AC mains or your site power or a generator. And it's perfect for temporary or portable ultra-low storage in a large form factor that can sit outside. It has onboard telematics that can be tracked remotely via satellite or LTE cellular, and it comes in two sizes, a 10-foot and 20-foot container. So if you need temporary storage because your building's bursting at the seams, or you're getting a retrofit, or you want to send materials at temperature with active cooling instead of passive cooling, with phase change materials like dry ice or paraffins or even gels, it's a really great solution. And let's wrap it up next. So today you've heard about some common problems facing our industry, from needing to improve yields, streamlining operations, processes, and running out of space to store ULT freezers. We've also learned more about the ULC family, and in particular the ULC-259. So it has high temperature uniformity at any temp between -20 and -80 degrees C. Multiple material handling solutions, and today, and more custom ones available upon request, and high density storage options that add storage capacity to your facility without the needs to increase site footprint. Finally, our redundant forced air convection technology brings it all together to provide tight uniformity, fast recovery time from door openings, and an Energy Star consumption performance. So contact us to learn more about the ULC family and our other family of products. And now I'll be happy to take any questions you have.
Thank you, Scott. To go to the Q&A, we please ask you that if you have any questions, if you will put them in the questions window and we will answer them accordingly. Okay, first question, Scott. Why is FARRAR adding numbers to the names of their ULC chambers?
It's a good question, one I get all the time. So bioprocessing customers' needs are evolving. So FARRAR recognizes the need for more customized solutions specifically around our chambers that provide maximum density and storage container flexibility for each customer and whatever tools they're using in terms of storage containers. So adding 190 and 311 and now the 259 helps customers quickly align with our capacity capabilities by identifying the units in their square footage. Globally, I apologize to those who think about square meters, but it's simpler in my mind, to remember the units in 3 digits instead of 4 because our units are so large.
Okay, another question, Scott. Let me see here. If my freezer is set to -80, it looks like the ULC-259 has a very big door. How long will the freezer take to recover after being open for 1 minute?
Well, that's a great question. And as I think back on my presentation, I think I inadvertently forgot to even talk about that. So thanks for the question. And the way I respond here is if you open the door for 1 minute, and when we open the door for a minute and we open an inner door as well, our door, and we keep it, the freezer is empty, our freezer can recover in between 20 and 22 minutes. So all the way back down to -80. So these are using free and air probes in the same spots that you might see an Energy Star test performed, and opening our door for 1 minute and then closing it. So pretty quick.
Thank you, Scott. Another question that we have, are the drawers and sliding shelves available on the 190 and 311 or just on the 259?
So currently they're released for the 259, but our team is in the process of making them also available on the 190 and 311 sizes. But the way I would answer is also, if you have a specific type of box or type of unit that you want to store, whether that's a box or a bottle or something else or a bag, contact us and we can work with you to use potentially whatever tools you're using today in your existing ULT and make sure that our solution can let you retrofit, or that we get you high density solutions. But we're very, very fast on doing that, and we have a dedicated team designed for material handling, as you saw earlier in the presentation around what we do for our walk-in chambers and what we're also doing for these ULC family. So again, yes, we have some, and we're putting the finishing touches on having those readily available, but contact us in the meantime and we'll work with you on exactly what you're storing.
Another question here, is the ULC-259 available for order? What's the part number and lead time?
Yes, the ULC-259 is available for order. The part number is ULC-259. There'll be some questions that that our commercial team will happily answer for you in terms of customizing that from the types of shelving and storage solutions you might want inside of it to whether you want it air or water cooled. They'll work with you on customizing exactly what you need. The lead time is about 4 to 6 weeks in the US and Canada, and about 6 to 8 weeks internationally to account for travel. These are manufactured in the United States, and so getting them over internationally takes a bit of time.
Thank you, Scott. Also, speaking of air-cooled and water-cooled, I do want to mention that there are handouts in your GoToWebinar experience. So if you need any help locating those, please let us know. They will also be available on our website, FARRARscientific.com. One more question, Scott. Let's see. You mentioned the tracer dashboard. What is that?
So our tracer dashboard is a tool that our trained commercial HVAC team has developed, and it's used all around the globe to monitor our HVAC units, whether they're HVAC, chillers, or even our refrigeration systems. They can all be integrated into View. And from there, many different points can be monitored. It's an internet-based solution that will track and automatically be monitored by our team or facilities team at your facility as well. And we can, if you desire, we also have the ability from that point to contact the right service provider, or if it's trained, we would do that work as well. I think there's a question that came in. Let me see if I can expand it on there to take a look. What is a realistic door? Hold on. So apologies, I try to like expand this a little bit so I can see a little bit tighter. It's one line, so
I can read it out for you, Scott. I can see it.
okay.
It says, what is a realistic door opening time for retrieving samples in such a large chamber?
It's a good question. So we've measured that, and we feel it's probably around 30 seconds. But if you're reaching, on average, if you're reaching towards the back of the chamber, though, if you have to fully extend to pull a cryo box out, let's say that's in the back of the freezer, it's about a minute. So that's why we cited a minute in our door opening time frame. I think when we've done time studies, it's usually quite a bit faster than that, but that would be worst case for sure. It's about a minute.
Another question came in, what low GWP solutions do you have for large scale walk-in solutions?
So at the moment, we're working with we just had a meeting about the refrigeration options that we're working on between CO2 and propane are two areas. And so I think about walk-ins can be such a large array in terms of like temperature range. So at the moment, for something that's a reach-in walk-in, like at -60 or colder, there isn't an available low GWP solution available from anywhere, just because the natural refrigerants at those temperatures are not available to be used. At the warmer temperatures, we're pulling together at the moment now a solid strategy around CO2 and likely propane. There's some other mixtures or synthetic refrigerants that our team's working on that are under pretty deep NDA that I can't talk about. Sorry to be kind of evading on that question. That's the best I can give you at the moment.
Doesn't look like we have any more questions. Those are really great questions. Thank you everyone for participating. Again, thank you, Scott, and thank you to all attendees for joining today. A brief survey will launch following this webinar, and any feedback is greatly appreciated. A recording of this presentation will be available on our website by the middle of next week. As a reminder, links to past webinars can also be found on our website at farrarscientific.com. Please share the recording or any information you have heard today, and we hope you'll join us for a future webinar.